Hello, welcome to this lesson under indices. My name is Mr. Daniel. I'm going to take you through how to understand the concept of indices very well and attempt solving questions under indices when you come across them. So thank you and stay as we are coming to look at the topic indices. Stay with me as we delve into the topic, try to understand everything about the topic. So fast forward, let's start with the concept of indices. And understanding the concept of indices, there are two basic things that you need to know under indices. One thing is the base, and then the second thing is the index. So when we are talking about indices, there are two concepts. That's the base and then the index. So let's understand what the base and the index are. So when I have a raised to the power n, a here is my base. A here is called the base. And then m is my index. So when I have a raised to the power m, a here stands for my base and m here is my index. So let's delve into the laws of indices. Basically, we have 5 laws of indices. We are coming to look at them one after the other. And the first law is the multiplication law. So the first law is called the multiplication. And bear in mind, multiplication is talking about the same base. When we are multiplying indices with the same base, we have a rule that we apply or a law that we apply, and that's what we are coming to look at. So multiplication of the same base. So let me indicate that. Okay, same base. So what does this law say? The law says that multiplying indices with the same base, you add the exponent. So for example, let me give you this example. A raised to the power n multiplied by a raised to the power n. So when we have something like this, a raised to the power n multiplying a raised to the power n, you see that a here is the base and a here is the base, and they are the same. So we have to add the exponent, and that is what the law demands of us. So here we have a raised to the power m plus n. So basically that's the first law or rule of indices under the multiplication. When we are multiplying numbers or indices with the same base, we add the exponents, and that is what we have just done here. A raised to the power n multiplied by a raised to the power n, we add the top numbers, which is called the index or the indices. So we have a raised to the power n plus n. Let's look at the second law. So the second law is also applied to same bases when we are dividing numbers, and that is division. We are dividing indices with the same base. What do we need to do? The law will tell us what we are coming to do. And the law states if we are dividing indices, or let me say, if you are dividing numbers with the same base, you need to subtract their exponents. Opposite of the first law, which is addition, you subtract the exponents. And let's have the same example here. A raised to the power m dividing a raised to the power n, or you can even write it as this: a raised to the power m divide a raised to the power n. And the law says that if you are dividing indices with the same base, you subtract the exponent, the top numbers. And here we are coming to subtract. So we get a raised to the power m minus n. So look at it, you see that is the opposite of the first law, which is addition of the top numbers or the powers. Here we are subtracting the top numbers or the powers, and we maintain the base because the base are the same. And that is the second law. Let's look at the third law, which is also about zero power or zero index. So the third law is talking about zero power or index. Any number raised to the power 0 is equal to 1. And that is what the third law is telling us. Any variable, any number raised to the power 0 is equal to 1. So if I have a raised to the power 0 or 2 raised to the power 0 or 5 raised to the power 0, all these one are equal to 1. So if I have 100 raised to the power 0 is equal to 1. 1000 raised to the power 0 is equal to 1. So that is the third law. That is a zero power. Any number raised to the power 0 is equal to 1. So a raised to the power 0 is 1, 2 raised to the power 0 is 1, and any number, no matter how light the number is, if it is raised to an index of 0, is equal to 1. And that is the third law. Let's look at the fourth law. And the fourth law is about the negative power or the negative index. So the fourth law is the negative power or index. And what does this law talk about? It talks about any number raised to the power negative, or any number that has a negative index or negative power exponent. It's equal to the reciprocal of the base. So let's look at that example or how to represent that. A raised to the power negative n is equal to 1 over a raised to the power n. Sorry, n. And then you have x raised to the power negative 1 is equal to 1 over x raised to the power 1. Or if you prefer write the 1, it doesn't matter. So that's the application of the fourth law, which is the negative index. It states that any base that is having a negative index or power is equal to the reciprocal of that base with a positive power. So here, you know that any number standing alone is over 1. That is, in mathematics, any number standing alone is having a denominator of over 1. So here, a is a over 1 raised to the power n. So a reciprocal of this means turn the number upside down. What number is down, make it come up. And what number that is up, you let it come down. And that is the reciprocal. So here, x over 1 raised to the power negative 1. A reciprocal of it will give you 1 over x raised to the power. The negative sign will now turn to positive. So here you can write the x raised to the power 1, or you decide not to write 1. It's also a general rule in math that any number standing alone is having a power of 1. So you might write the 1 here, but if you understand math very well, you don't need the 1 here. Just write 1 over x, and that is the same as this negative index. So let's look at the fifth law. Fifth law is the power of the power. And what does this law talk about? If any base has 2 exponents or powers, the result is by multiplying the 2 powers or exponents. So let's look at an example here. A raised to the power n inside the bracket, and outside the bracket we have another power n. So the result of this one will give us a raised to the power n multiplied by n. Now it will give us a raised to the power n in mathematics. So here we are having a raised to the power 2 different exponents, and that is n and n. So the result of this is by multiplying the exponent, which are the powers, together. And that is what we did here, and we got a raised to the power n multiplied by n. And that is the same as a raised to the power n in mathematics. So basically here are the 5 simple laws, or here are the 5 laws that we apply in solving any indices question. We are coming to look at sample questions in which we are applying the laws individually to solve questions related to indices. So take note of all the indices that, all the laws that we dealt with from the beginning, and see how we are going to apply them when we are coming to solve the examples. So Let's go into the examples. So now we are going to solve these questions by applying the laws that we just learned, the 5 laws in solving them. So straightforward, let's begin with the first question. Let me divide my board, but my board is not enough, so let me divide and then we need to cover the space. So question 1, we have 2 raised to the power multiply 2 raised to the power 4. Yes, this one is obviously the first law, which is the multiplication law, right? And what do we need to do? Since the base are the same, 2, we add the exponents, and that is the solution, straight away. So here we have 3 raised to the power 3 plus 4. And 2 raised to the power 3 plus 4 will give us 2 raised to the power 7. As simple as that. So that is the application of the first law in solving the first question or the first example. So let's go to the second question. 3 raised to the power 3 multiplied by 3 raised to the power -1. Here is similar to the first one that we solved with the application of the first law, right? Because of the multiplication sign. So when you see the multiplication sign, what we need to do is that we are adding the exponent. So here we add the exponent straight away. So 2 raised to the power 3 plus -1. And take note, anytime you have a negative and a positive number coming together, the negative number is stronger than the positive. So here we have to eliminate the positive sign. So it will be 3 minus 1 instead of 3 plus 1 or whatever you think. So the negative sign is stronger than the positive. So you can't have the two signs at the same time. So because the negative sign is stronger than the positive, the result will turn to 3 raised to the power 3 minus 1, and that will give us 3 raised to the power 2. So that's the solution for the second question. Let's look at the third one. The third one is talking about power of the power, 2 raised to the power -3, all inside the bracket to another power. And this is the 5th rule or is it the 4th rule? I can't remember. This is the application of the power of the power. So we have the base raised to 2 different exponents. So what we need to do, the simplification is just to multiply the 2 exponents together, and that is 2 raised to the power -3 times 2. And that will result will give us 2 raised to the power -6. Okay? That will give us 2 raised to the power -6. The result is multiplying the 2 exponents together. Okay, so now let's look at the fourth one. The fourth example. Sorry, my numbering is wrong. This is the fourth example, and this is the 5th. Sorry. So let's look at the fourth one. The fourth one is the second law, which is the division law. 9 raised to the power 5 divided by 9 raised to the power 4. So the second law was talking about what? When we are dividing numbers with the same base, we subtract the exponent, right? So here we apply it. So we have the same base 9 now, so we maintain 9 and then subtract the exponent 5 minus 4. And that one will give us 9 raised to the power 1, which is equal to 9. I told you about any number raised to the power 1 is the same number. So when we have 1 raised to the power 1 is 1, 2 number raised to the power 1 is that same number. So this is it. So let's go to the 5th example. And that is 5 raised to the power 2 dividing 5 raised to the power -2. What do you think about this question? Very simple. So the application of the second law, which we have done here, we are adding the exponent. Sorry, we are subtracting the exponent. But in this case, it's going to turn to addition. You see how. So the solution is by subtracting the powers, right? So we have 5 raised to the power 2 minus 2. Take note. It's not 5 raised to the power 2 because the 2 is only negative. So 5 raised to the power 2 minus this -2. So when we have negative sign coming together, they turn to positive. So negative multiply negative, you get positive. So this one will give you 5 raised to the power 2 plus 2. 5 raised to the power 2 plus 2. And 5 raised to the power 2 plus 2 will give you 5 raised to the power 4. So 5 raised to the power 4. That is the solution to the fifth question. 5 raised to the power 4. We were supposed to subtract the exponent, but here, because of the negative 2, when we are subtracting, it will turn to positive, and that is why we got 4. Your result, you might be thinking we have had 5 raised to the power 0, but here, because of the negative sign, it has turned to 5 raised to the power 4. Okay? So the fifth question, I will allow you to solve it as you have understood what we've done so far. So what we do down is so we have question 6, 2 raised to the power negative 3, 2 raised to the power 1 divided by 2 raised to the power 0. So this one, I'll allow you to solve it on your own. Just apply the simple rules that we have learned to solve this one and leave your answer in the comments. If you find this video very useful, don't forget to like, share, comment, and subscribe. Follow for more videos. Thank you for watching.